For lesson 7, we're going to do a little bit more work with finding volume. So determine the volume of the composite solid shown below and round your answer to the nearest hundredth. So the first thing we need to do is we need to realize that we're talking about we need the volume of a cone and we need the volume of a hemisphere. So we'll work on the cone part first. 1/3 pi r squared h is going to be our cone formula. So if we look at what we got here, we have a radius of 5 and a height of 12. So we're going to be 1/3 pi 5 squared times 12. And what I'm going to do is, just to make my life a little bit easier for now, I'm going to keep my answer in terms of pi. So if I do 5 squared times 12 times 1/3, I get 100 pi for my cone. And then if I do my hemisphere, 4/3 pi r cubed, and then it's going to be times a half, because we only have half of a sphere. So that radius for the cone also goes to the radius of our sphere. So 4/3 pi 5 squared times a half. So as we do that, we get, if I leave this, I get a decimal, so if I leave it as a fraction, I get 250 over 3 pi. So when I take those two numbers, 100 pi plus 250 over 3 pi, and again, they're going to be rounded to the nearest hundredth. So 100 pi plus 250 over 3 pi, that gives me 575.96 units cubed. All right. So again, I just left my answers in terms of pi to make everything easier, and then went ahead and solved by adding them together at the end. 2. A rectangular bathtub is filled 2/5 of the way with water. The bathtub has a length of 8 feet, a width of 3 feet 6 inches, and a height of 2 feet 8 inches. Determine the volume of the water in the bathtub to the nearest cubic foot. So we've got things in different units, so we have to be careful here. So we want everything in feet. So 3 feet 6 inches is really 3.5 feet, and 2 feet 8 inches is really, you could do it as like 2.66 repeating, but you can make it as a mixed number, but everybody knows that I hate mixed numbers, so we're going to go with 8 over 3 feet. Again, you could be 2 2/3, that's fine as well. If you're going to use the decimal, please make sure that you use a lot of sixes in your calculator. So the volume is going to be length times width times height. So we're 8 times 3.5 times 8/3. And when we do that in our calculator, we are going to get 74.6 repeating cubic feet of water. Now, in this case, you can afford to just multiply it by 2/5, because in a rectangular bathtub or a rectangular prism, the volume is the same throughout. So you don't have to worry about creating a proportion and scaling it the way we do with some of our cones. We can go ahead and just multiply this by 2/5 right away. And when we do that, we get 29.8, which gives us 30 cubic feet of water. All right. So again, find the volume full and then multiply it by 2/5 at the end. A cup in the shape of a right circular cone is being used to fill a bucket in the shape of a right circular cylinder with sand. The cone has an altitude of 6 inches and a radius of 3 inches. The bucket has a height of 24 and a diameter of 20. How many cups of sand would fit in the bucket without it overflowing? So everything is in inches, which is good. So the first thing we'll talk about is the cone cup. So the cone has an altitude of 6, or a height of 6. It's got a radius of 3. So if we look at the volume of the cone, we're 1/3 pi r squared h, which gives us 1/3 pi times 3 squared times 6. And again, I'm going to leave this in terms of pi to make my life easy. So you get 18 pi is the volume of our cone. So now if we find the volume of our cylinder, it says it's got a height of 24 and it has a diameter of 20, which really means it's got a radius of 10. So if we find the volume of our cylinder now, we are pi r squared h. So pi times 10 squared times 24. And when we do that in our calculator, again in terms of pi, we get 2,400 pi. So if we want to figure out how many cups of sand would fit in the bucket without overflowing, we'll divide the two. So 2,400 pi divided by 18 pi, your pi's end up canceling and you end up getting 133.3 repeating, which means our answer would be 133 cups would fit in there without the bucket overflowing. All right, so again, you find the two volumes individually, divide them at the very end, and then we get, without rounding up, 133 cups.